So in terms of powers and roots, essentially need to be familiar with at least these powers. So knowing the first 3 or 4 powers of 2, 3, 5, 7, and 10. Okay, so however you want to practice those, it's up to you. You might want to make little palm cards and quiz your friends, make some Excel sheet that'll auto-generate it. Okay, but need to know these powers. In a similar way, these square numbers, definitely need to recognize all those square numbers to be able to do any squaring or square rooting, as the case may be. Okay, so little tips that might help you out. So say you need to do 3 to the power 4. You can do this with your fingers. Start with 3 to the power 1, which is 3. And then when we multiply by 3, we'll get 3 squared. So each of these multiplying by 3, 3 squared is 9. And then we'll multiply by 3 again. We're just counting how many times we're multiplying by 3 with our fingers. 3 cubed is 27. And then multiply by 3 again. 3 to the power 4 being 81. Okay, so really just using your fingers in the exam. No one's watching. Might be an invigilator, who cares? Just going, alright, I got to do 5 cubed. So 5 times 5 is 25, times 5, 125. Just counting how many powers you have on your finger. Okay, so you get 81 here. Okay, when we're looking at some of these cubed roots and fourth roots, need to remember this problem is really asking us what number cubed gives me 125. So you're really just rolling through your memory of cube numbers, thinking, hey, 2 cubed, that's 8, that's no good. 3 cubed, that's 27, that's no good. Maybe 4 cubed, that's 64, no good. 5 cubed, that's 125. Okay, so 5 is the magic number there, so 5 will be my my cubed root. Okay, that square root root radical shouldn't go the whole way. And there's some hints as well that we probably should have guessed that was a 5 because we saw the number ended in 5, and we know that all the powers of 5 have an ending of 5. So lots of little tips there, but really need to be spending some time, if we don't already, knowing all of those powers. There are some little tricks we can use with some of these power and root problems. So there is an index law that's a on b to the power n is a to the power n on b to the power n. Basically, if you have, and same with multiplication, if there is division or multiplication inside the brackets and there's a power outside, you can expand the power inside the bracket. Okay, you can't do it if there's an addition. Okay, we're definitely not doing any of these guys. Okay, but we can definitely use those 2 laws, and we might see how it's easy to simplify some of these problems. So 30 squared on 15 squared, you might be thinking, I don't want to play with these big numbers and these fractions. I don't either. Okay, so since they're both squared, it could have come from something like this, 30 on 15 squared. So easier for me is to simplify 30 on 15, which is 2 squared, okay, to give me 4, and I don't have to go playing with huge numbers. Okay, if I'm asked to find the square root or any root of a fraction, okay, remember square root is really to the power of a half, so we can imagine that power of a half being given to both 4 and 25. So it's really square root of 4 on square root of 25. I know both of these. This is 2 on 5. Okay, so some little tips. Okay, you might come across some bigger problems where it's already expressed in power notation with the fractional powers. That's all good. I remember how to do this. So 2 plus 7 is 9, and instead of writing 9 to the power of a half, it might be easier for me when I'm evaluating these to just think of it as square root of 9. Okay, and same deal here. 2 minus 1 is 1 to the power of a half. I'm just going to write the square root instead. Okay, so I really have 3 on a half, subtract 1 on a half. I know that dividing by half is the same as multiplying by 2, So it's really 6, take 2 to give me 4. Okay, lots of different ways you can do it, but that should help us out. Okay, and then we do get given some sort of more interesting ones, but we should be able to just work through this and get there. Just sort of doing this one as a demo. So I have e to the power negative 1 on root 2 squared. So I'm going to square both of the things inside there. So I'm subtracting 1 squared on root 2 squared. Square roots and squares cancel each other out. So I'm really after e to the power negative 1 squared on 2. Okay, so let's see how this ends up. Okay, so it's really e to the power negative 1/2. I can multiply all these fractions. So 2 on root 2, and I have e to the power of negative 1/2 on top as well. So looking at this, I might think, hey, there's nothing I can do to simplify these fractions. Just remember that 2 on root 2 is the same as 2 on 2 to the power of 1/2. That's the power of 1. I can subtract these fractional powers and be left with 2 to the power of 1/2. Okay, so I really have 2 to the power of 1/2 on the top, which is really root 2, and this negative power I'm going to bring to the bottom and make it a positive power. Okay, so putting both of them in square roots, this is how we get to what that target in the solution for this problem is. Okay, so they do get nasty, but there's lots of different ways you can work your way through some of these problems, probably involving going back to maybe like a year 10 textbook, 10A textbook, looking at some index laws practice.